Hello everyone, my name is K. Rambabu, Assistant Professor, Department of Mechanical Engineering. I am handling mechanics of fluids and hydraulic machinery. Introduction to fluid statics we are going to discuss. Before going to discuss syllabus, course objectives. To understand the basic principles of fluid mechanics, to identify various types of flows, to understand boundary layer concepts and flow through pipes, to evaluate the performance of hydraulic turbines, and to understand the functioning and characteristic curves of pumps. Course outcomes. After successful completion of this course, students can able to explain the effect of fluid properties on a flow system, able to identify type of fluid flow patterns and describe continuity equation, to analyze a variety of practical fluid flow and measuring devices, utilized fluid mechanics principles in design and demonstrate boundary layer concepts, to select and analyze an appropriate turbine with reference to given situation in power plants, and to estimate performance parameters of given centrifugal and reciprocating pump. Unit 1, Fluid Statics. Dimensions and units, physical properties of fluids, specific gravity, viscosity and surface tension, vapor pressure and their influence on fluid motion, atmospheric, gauge and vacuum pressures, measurement of pressure, piezometer, U-tube and differential manometers. Unit 2, Fluid Kinematics, Fluid Dynamics and Measurement of Flow. Fluid kinematics, streamline, pathline and streak lines and stream tube. Classification of flows, steady, unsteady, uniform and non-uniform, laminar and turbulent, rotational and irrotational flows. Equation of continuity for one-dimensional flow and three-dimensional flow. Fluid dynamics, surface and body forces, Euler's and Bernoulli's equations for flowing along a stream line. Measurement of flow, pitot tube, venturimeter and orifice meter, flow nozzle. Momentum equation and its application on force on pipe bend. Unit 3, Closed conduit flow, Reynolds experiment, Darcy-Weisbach equation, minor losses in pipes, pipes in series and pipes in parallel. Total energy line and hydraulic gradient line. Boundary layer concepts. Definition, thickness, characteristics along thin plate. Laminar and turbulent boundary layers. Boundary layer in transition. Separation of boundary layer, submerged objects, drag and lift. Unit 4, Basics of turbomachinery, hydrodynamic force of jets on stationary and moving flat inclined and curved vanes, jet striking centrally and tip velocity diagrams, work done and efficiency, flow over radial vanes. Hydraulic turbines, classification of turbines, heads and efficiencies, impulse and reaction turbines, Pelton wheel, Francis turbine, and Kaplan turbine. Working proportions, work done, efficiencies, hydraulic design, draft tube theory, functions and efficiency. Performance of hydraulic turbines, geometric similarity, module and specific quantities, characteristic curves, governing of turbines, selection of type of turbine, cavitation, surge tank, water hammer. Unit 5. Centrifugal pumps, classification, working, work done, barometric head, losses and efficiencies, specific speed, performance characteristic curves, NPSH. Reciprocating pumps, working, discharge, slip, indicator diagrams. Textbooks, hydraulics, fluid mechanics and hydraulic machinery, Modi and Seth. Fluid mechanics and hydraulic machinery by R.K. Rajput. Reference books, Fluid Mechanics and Fluid Power Engineering by D.S. Kumar, Fluid Mechanics and Machinery by D. Ramadurgaya, Hydraulic Machines by T. R. Banga and S. C. Sharma. These are the references, URLs. Introduction. What is fluid? Fluid is a member which undergoes continuous deformation under the action of shear stress. Under the action of shear stress. Fluid is further divided into liquids and gases. The liquids and gases exhibit in different characteristics on account of their different molecular structure. Spacing and latitude of the motion of molecules is large in gas and weak in liquids and very strong in solid. It is due to these aspects that solid is very compact and rigid in form. Liquid accommodates itself to the shape of the container and gas fill up the wall of the vessel containing it. Fluid mechanics cover many areas like design of wide range of hydraulic structures like dams, canals, wells, etc. and machinery, pumps, turbines, etc. Design of complex network of pumping and pipelines for transporting liquids, flow of water through pipes and its distribution to service lines. Fluid control devices, both pneumatic and hydraulic, design and analysis of gas turbines and rocket engines and aircraft. Power generation from hydraulic, steam and gas turbines. Methods and devices for measurement of pressure and velocity of a fluid in motion. Introduction to fluid mechanics. Fluid mechanics is the branch of science which deals with the behavior of the fluids, liquids or gases at rest as well as in motion. It deals with the statics, kinematics and dynamic aspects of fluids. Fluid statics. The study of fluids at rest is called fluid statics. Fluid kinematics. The study of fluids in motion where pressure forces are not considered is called fluid kinematics. Fluid dynamics. The study of fluids in motion where pressure forces are also considered for the fluid in motion. That branch of science is called fluid dynamics. Units and dimensions. A dimension is a name which describes the measurable characteristics of an object such as mass, length and temperature, etc. A unit is accepted standard for measuring the dimension. The dimensions used are expressed in four fundamental dimensions, namely mass, length, time and temperature. Mass in kgs, length in meters, time in seconds, temperature degree centigrade or Kelvin. Density, mass per unit volume. The standard units is kg per meter cube. Newton, unit of force expressed in terms of mass and acceleration according to Newton's second law motion. Newton is the force which when applied to a mass of 1 kg gives an acceleration 1 meter per second square. F equal to mass into acceleration is equal to kg meter per second square, which is equal to newtons. Pascal. A pascal is the pressure produced by a force of Newton uniformly applied over an area of 1 meter square. Pressure is force per unit area. Units are Newton per meter square, which is equal to Pascal. Joule. A joule is the work done when the point of application of force of 1 Newton is displaced. Work is force per unit. Newton per meter or which is equal to joules watt. A watt represents a work equivalent of joule done per second. Power is work done per unit time. Units are joule per second, which is equal to watt. Physical properties of fluids. Physical properties of fluids are characteristics that describe how a fluid behaves under different conditions such as pressure, temperature, and applied forces. Physical properties of fluids are density, specific weight, specific volume, specific gravity, viscosity, compressibility, surface tension, capillarity, bulk modulus, and vapor pressure. Some of the definitions of fluid properties. Density or mass density. Density is the measurement of how tightly a material is packed together. The density or mass density of fluid is defined as the ratio of mass of the fluid to its volume. Thus, the mass per unit volume of the fluid is called density. It is denoted by rho. The unit of mass density is kg per meter cube. Rho equal to mass of fluid by volume of fluid. The value of density of water is 1 gram per centimeter cube or 1000 kg per meter cube. Density of liquid is considered as constant. Density of gases changes with the variation of pressure and temperature. Specific weight or specific density or weight density. It is the ratio between the weight density of the fluid to its volume, or the weight per unit volume of the fluid is called weight density. It is denoted by small w. The unit of weight density is Newton per meter cube. Weight density is equal to weight of fluid by volume of fluid. Weight of fluid is equal to mass of fluid into acceleration due to gravity to the volume of fluid. Then mass of fluid into acceleration due to gravity by volume of fluid. We can represent specific weight is equal to rho into g, rho g. The value of specific weight or weight density for water, rho into g, is equal to 1000 into 9.81 is equal to 9810 Newton per meter cube in SI units. Specific volume. It is defined as the volume of fluid occupied by a unit mass or volume per unit mass of fluid is called specific volume. Specific volume is equal to volume of fluid by mass of fluid. That is equal to, we can represent 1 by mass of fluid by volume of fluid. That is equal to 1 by rho. The specific volume is equal to 1 by rho. It is the reciprocal of mass density. It is expressed as meter cube per kg and is commonly applied to gases. Specific gravity. It is defined as the ratio of weight density or density of fluid to the weight density or density of standard fluid. For liquids, the standard fluid taken as water, and for gases, the standard fluid taken as air. The specific gravity is also called relative density. It is a dimensionless quantity and it is denoted by S. Specific gravity is equal to weight density or density of fluid by weight density or density of standard fluid. Specific gravity for liquids, weight density of liquid or density of liquid to the weight density or density of water. The weight density of liquid is equal to S into weight density of water. We can represent S into rho into G. Weight density of liquid is equal to specific gravity into weight density of water. The weight density of water is rho into G. We can express specific weight density of liquid is equal to specific gravity into weight density of water, that equal to S into rho into G. Rho is 1000 for density of water and G is 9.81 Newton for meter cube. Density of liquid, S into density of water, S into 1000 kg for meter cube. Specific gravity for gases, weight density or density of gas to the weight density or density of air. Thank you.